All right, so we have all our if-then statements, and now we want to take a look at deductive reasoning, which is a system of reasoning used to reach conclusions that must be true whenever the assumptions on which the reasoning is based are true. So if we have certain assumptions which are true, and we use a system of if-then statements and we logically connect them, and that is our system of deductive reasoning, connecting these statements, then the conclusion must be true. Deductive reasoning is reasoning in which the conclusion is necessitated by or reached from previous known facts. So we use facts and then we base conclusions on those facts. This is distinguished from inductive reasoning, where there's a high probability, but we are not ensured that the conclusion is true. So inductive, we're looking at patterns, we're drawing conclusions based on patterns, but it's possible that our conjecture, our reasonable estimate of what is true, is not in fact correct. So deductive reasoning, it must be true. Inductive reasoning, there's a high probability of the conclusion, but it's not necessitated to be true. Okay, so, and these are laws. If it's a law, it must be so. So these are laws of deductive reasoning. If I give you a conditional statement, if P then Q, and it is true. So I have if P then Q. If it rains today, then I'll stay home. And then you find out that, in fact, it rains. You may then conclude that I stayed home. Because this is a rule, it's a law. I told you that this would happen no matter what. If it rained, I would stay home. It rained, you concluded I stayed home. You used the law of detachment to conclude that. All right, so P is our hypothesis, rains. Q is stay home. If I give you that it's raining, then you are allowed to conclude I will stay home. Am I given P? It rained today. That was P. Yes. This is the law of detachment. Okay, let's take a look at another example here. If two numbers are odd, then their sum is even. This is true. Okay? 3 and 5 are odd numbers. Can you then conclude that the sum is even? Is this an example of the law of detachment? Did I give you P then Q as a true conditional? I then detach just the P part, and you therefore, that's what the 3 dots mean, concluded Q. So is that the law of detachment? Yes, it is. And just a footnote here, we have to be very careful that we cannot conclude the converse. If the sum of two numbers is even, can we conclude that the numbers were odd? No. 2 plus 6 are 8. So we just have to be careful. The law of detachment, I have to be given the hypothesis, and then you draw that conclusion. All right. If I am happy, then I sing. This is true. I'm saying this. It is a true conditional. I am singing. You concluded that I am happy. Is this the law of detachment? P then Q. Did I give you P? And did you therefore conclude Q? Let's take a look. P is happy, and sometimes I write the P right over the top. P is happy. Q is sing. I am singing. That's Q. So this is the law of detachment, but this is not what we're given here. If P, then Q. I gave you Q. You concluded P. This is not the law of detachment. I cannot draw that conclusion. Okay? If I'm happy, I sing. Maybe I also sing when I'm sad. It doesn't say anything about that. Okay. All right, so that's the law of detachment. if P then Q, and I give you P, and you conclude Q. The law of contraposition. Again, I'm always going to give you a true conditional. If it rains today, then I'll stay home. I did not stay home. The conclusion, it did not rain. All right. So, this is P, it rains. Q, I stay home. I give you not Q, and you conclude not P. That's the law of contraposition, and it is always true. As long as the conditional is a true conditional, you can use the law of contraposition. All right, let's see if this one says it. If a zippity is round, then it is a glit. So if we have a zippity and it's round, we'll call it a glit. I have an object and it's not a glit. Therefore, the object is not round. Okay, so being a zippity, if a zippity is round, so I have a zippity that's round, then I can call it a glit. But this is not a glit, not Q. Therefore, I can say that it's not P. Yes, this is the law of contraposition. Okay? So we have to identify our P and Q. And I usually write it right over the top. Of course, you could write it on the side that a zippity is round. If the zippity is round, then it's a glit. It's not a glit, therefore the object's not round. Okay, so we've got two so far, law of detachment and law of contraposition, and these follow right from our if-then statements. Okay, the third law is called the law of syllogism. It says, if P then Q and Q then R are true conditionals, then P then R is true. All right? So our first premise or our first conditional statement is, if two angles are vertical, then they are congruent. So P is vertical angles, Q, they are congruent. Our next premise is, if two angles are congruent, which is Q, then they are equal, which is R. Okay? Now, the conclusion is, if two angles are vertical, which is P, then they are equal, which is R. In other words, the Q statement links these two together. It's like an overlap. So if P then Q, Q then R, I can go directly from P to R. This law is similar to the transitive property. The transitive property of real numbers. And, oh, let's see, I could make something up now. If 2 plus 3 equals 5, and then if 5 equals 4 plus 1, then I can conclude that if I have 2 plus 3, it equals 4 plus 1. 2 plus 3 is P, 5 is Q, 5 again is Q, 4 plus 1 is R, so therefore 2 plus 3 equals 4 plus 1. All right, and that's the transitive property of real numbers, and you can see how there's that overlap. All right, does the following illustrate the law of syllogism? If I read the New York Times, P, then I am an informed citizen, Q. If I'm an informed citizen, Q, same thing, so we call it Q again, then I vote R. And that's something totally new that we haven't seen before, voting, so we have to give it a new label, R. I vote, which is R, therefore I must read the New York Times, P. If P then Q, if Q then R, then if I have R, I can conclude P. Is that the law of syllogism? No, it is not. We actually call this a false chain pattern. Okay? And so the answer is no. All right, so now what we want to do is identify some of these as our 3 types of laws. And notice there's 4 questions here. These laws are laws of deductive reasoning. There are 3 of them. If P, then Q, I give you P, you can therefore conclude Q. It's called the law of detachment. If P, then Q, I give you not Q, and you conclude not P. That is the law of contraposition. And finally, if P, then Q, if Q, then R, and these are true statements, and I give you P, you can conclude R. That would be called the law of syllogism. All right, so it's really easy when you start putting P's and Q's next to them. If you try to logically think, sometimes it doesn't work. All dogs owned by Mary Lou are greyhounds. P is dogs owned by Mary Lou. They are greyhounds. It's true, it's a rule, it's a law. Rex is not a greyhound. So how do I write not a greyhound? Not a greyhound. Therefore, Rex is not P owned by Mary Lou. Is this one of the laws of deductive reasoning? Which one? And this would be yes, contraposition. Okay, and notice these are not in if-then form. That's all right. As we think about them, we think about them in if-then form. All men are mortal. If I am a man, then I am mortal. So being a man is P. Therefore, I am mortal, Q. Socrates is a man. So I'm giving you P again. Socrates is mortal. You're concluding Q. Is this law a law of deductive reasoning? Yes. It is detachment. Okay. All right, so this one, no bald eagles are lizards. Lizards, Q. Are amphibians, R. No bald eagles, P. Are amphibians, R. This is deductive reasoning. This is law of syllogism. If 2 angles are vertical, then they are congruent. So if 2 angles are vertical, 2 angles being vertical is P. Q is there congruent. F and G are not congruent, not Q. Therefore, I say that F and G are, oh, there's a typo. I think I meant not vertical here. If 2 angles are vertical, they are congruent. They are not congruent, not Q, therefore not P. Law of contraposition. Okay, and there's the homework, and it's in the book. Very good.